Here's an example to illustrate the concept that the definite integral gives you the area under a curve. So, we have a function, f of x, and we have an interval from a to b. We want to determine the area under the curve over the interval from a to b. And the way we interpret that is that if we look at an infinitesimally thin element that has a width of dx, an infinitesimally thin width with a height of f of x, the area of that element, of that infinitesimally thin rectangle, would have a height of f of x and a width of dx. And what the definite integral gives you is, in a sense, the sum of all possible elements from a to b, thus the integral from a to b of f of x, the height, times the width, dx. So in our example, we're going to find the area under the curve y equals 2x to the third minus 5x squared plus 2x plus 2 over the interval from 1 to 3. So the picture is going to look something like this. Comes back down and goes up again. And we're looking at the interval from 1 to 3. So that shaded region right there, we're looking at what is the area of that region. So the way we can do that is the area would be the definite integral from 1 to 3 of 2x to the third minus 5x squared plus 2x plus 2. And don't forget dx. The height, which is the function, the width of all the elements, dx. And then the integral from 1 to 3, all possible elements from 1 to 3. So, to actually go ahead and evaluate that, the integral of each of the terms would be then 1 half x to the fourth minus 5 thirds x to the third plus x squared plus 2x evaluated from 1 to 3. And again, when you do a definite integral, you do not need the plus c. So, were we to evaluate and simplify, the value at 3 would give you 21 over 2. And then you would subtract the value at 1, which in this case, if simplified, would be 11 over 6. So, simplifying that value, we get 26 thirds as being the exact value of the area under the curve, 2x to the third minus 5x squared plus 2x plus 2.